Lesson 4, identifying characteristics of linear functions from a given equation. The goals for this lesson are to identify and describe the characteristics of a linear functions, including leading coefficient, slope, and the behavior, y-intercept, x-intercept, domain, and range. So this lesson covered all of these characteristics. Now, just a background before I go into more detail. Now, equations have a straight line are called linear equations. So we have a straight line graph. Now, we've done a fair amount of straight line graphs, and one of them in the previous lesson, we looked at example 2 in the previous lesson. And here we have a linear regression. Remember, a regression is when you're comparing two variables, and the two variables being compared here are degrees in Fahrenheit and degrees in Celsius. So when we're given a set of data, we plot that set of data, create a scatter plot, and then we derive the line of best fit, and from that line of best fit, an equation. Today, we are going to examine what this equation means. What is x, what is y, what does these numbers mean? So that's our main goal for today's lesson. So we call the equation of a straight line linear equation, or a straight line graph. Sometimes these are referred to as linear functions. So far we've been calling them linear functions. Now, in the previous lesson, we saw that we could determine an equation if we were given a table of data. So here we have our table of data. We plot that in a scatter plot, and we derive the equation. But we use a graphing calculator. The question is, can you do it without a calculator, without a graphing calculator or a graphing technology? In today's lesson, we are going to use a set of data, graph it on graph paper, the scatter plot, and derive this equation without using a graphing calculator. So let's go to equation of a straight line. Now, I put a link where you could find more information about the equation of a straight line. Now, the equation of a straight line is usually written in this way, y equals mx plus b. Now, if you look at your previous linear regression equation, another example, the one I'll give you here is this one on temperature. If you compare it, y is equal to 0.56x minus 17.78. This is an example of why the m is here is 0.56. The x remained as a variable. In this case, the x was temperature, and the y, the x was temperature in Celsius, it was Celsius, and the y was Fahrenheit. Oh, sorry, this is Celsius is y, and x is Fahrenheit. Just look at my scale here. Celsius and Fahrenheit. So the x refers to the temperature in Fahrenheit, and the y refers to it in Celsius. So it's very similar. Now, what does it mean? If we have a line, it has a slope, or the steepness of it. This steepness here is called m, or the slope for simple. So whenever you see an equation, y equals a number x times something else, it means this is the slope, the steepness of the slope. And we'll talk what the slope means. The b refers to where it crosses the y-axis, called the y-intercept. So y is equal to m, which is your slope or gradient. Your x is your variable. So y is a variable, x is the variable. The m is your slope. And the b is referred to the y-intercept. So wherever x is 0, y, where the line crosses the y-axis, refers to the y-intercept. So y is how far up or down. So it refers to, in this case, if we have, look at this equation here, it's y equals the slope now, and I'll look at this here, and the slope is defined as rise over the run. It's a ratio, so the slope here is equal to the rise over the run, or the change of y, 2 minus y1 over x2 minus x1. You don't have to memorize these yet, but I just want to make you familiar with what the slope is. Now, we can derive the slope, especially if it's on these, we pick 2 points on the line, then we construct a right triangle, and we look at the rise on the vertical line here, how much it goes up from here. So you have 1, 2, 3, 4. So the rise in this case is 4, and the run refers to the distance from, in this case, it would be 2, 1 to here. This is your run. That's 2. So the slope here would be 2, which is equal to m. So the m in this case would be 2. The x remains the variable, y is equal to. Now, where does it cross the x-axis? At 1. So this line has the equation y equals 2x plus 1, the slope, the steepness of the slope. No matter where you were to pick 2 points on the line, and you draw a triangle here, perpendicular right triangle, you still have 1, 2, 3, 4 over 2, rise over the run. But the slope of a straight line is constant no matter what 2 points you pick and derive the slope. So repeat this now. Your m then is your slope, and your y-intercept is the b. And here, where we have what? Change of y with change of x, we find the slope. How do we find m and b? So here we have a line, and if this line were to continue here, we find the slope by picking 2 points on the line, then construct a right triangle, and the rise, the change of the y, we call it, or a change of x, or the rise over the run. Rise over the run might be much simpler to remember. So let's look at another example here. And this is what we just did here, and it's a bit clearer, right? So here we have a line. The y-intercept here is 1. So remember, y equals your slope times x plus y-intercept, or y equals mx plus b. So the 2 things you need to derive are the slope and the y-intercept. First thing here, the y-intercept here is 1. So this will be plus 1. The slope now, you select 2 points on the line that you can read off. And here, this point is right on the x-axis line of 1. And this point here is right on the y-axis point at 1. So we construct the right triangle. We count up 1, 2, and horizontally we have 1. So we say the slope here is 2 over 1. Y is equal to. Remember, the y and the x are the variables, so we leave what they are. So we have y is equal to 2x plus 1. So the calculated gain is the slope, the change of y over change of x, or the rise over the run. Here's another example of, here we have a line. Now this line crosses at 1 here. Well, this time the slope is 1 because the rise here is 2 and the run is 2. So 2 over 2 is equal to 1. So if I were to write this equation out, it would be y is equal to mx plus b, or m. So these are the two things you'll be deriving. Your m is 1, so y is equal to 1x, plus your y-intercept here is 1. So y is equal to x plus 1. So since the 1 is understood, it's not indicated here. So slope, so if you were to ask what's the slope here is 1. And the y-intercept is also 1. Here's another example. Now this y-intercept is off a little bit. It's probably around 1.9. This here is 1. So we can say y is equal to mx plus b. Or sometimes I'll put a box around here, meaning that these are the two things I need. My y-intercept, y is equal to, I'll put a box here for my slope. It's around 1.9, I think. Yeah, 1.8 or 1.9 approximately. The slope now, we look at here, is 3 over 6, which is 0.5. So we can say the slope is 0.5. So y is equal to 0.5x plus 1.9. Here are some other examples of slope. Pick 2 points here. The rise is 3, the run is 3. So its slope is 1. Here the rise is 4. And the run is 2. The slope is 4 over 2. And in this example, you have the rise is 3 and the run is 5. So the slope is 5, 3 over 5, or 0.6. So this line here, if you look and now we're comparing the slope will indicate to you the steepness. The greater the number, the steeper the slope. Here we have a slope of 2 compared to a slope of 0.6. A slope of 2 is much steeper than 0.6. Slope of 1 is much steeper than a slope of 0.6, but not as steep as the slope of 2. So the value of the slope tells you the steepness of the slope. The line is steeper, so the slope is larger. So the larger the slope, the steeper the line. This is another thing you have to remember. We did a question which was negative. If you have a negative slope, it's going the other direction. So if you have a line going from quadrant 2 to quadrant 1, that's a negative slope, indicating the slope here. The slope is going from quadrant 2 to quadrant 4. So this is a negative slope. And here's an indication of it. If you're going downhill, it's a negative slope. If you're just going in a, like Winnipeg is pretty flat, the slope is 0. But if you're going uphill, say going up a mountain, the slope is positive. So far, most of the slopes we looked at were positives. There was only one negative one we looked at already. So if you look back at our practice examples of linear regression, this is the one with houses and the price of the size of houses, it's positive slope. It's going up. Same as the one with temperature. So the slope is going up. And rental. Now let's look at this example of the slope here. If we were to construct, we pick 2 points. Now the y-intercept here is 150, so it crosses the line of 150. So y equals mx plus b, so your intercept is 150, crosses the line here. The slope now, what you want to do, you find 2 points that you can read off. And let's see, what would be approximately here and here. And you would construct the right triangle. Now this is not as precise. You have 1, 2, 3, 4. Okay, so we have 2 here, the rise, and 4. Now this would give us a half, but the slope tells me here is 2.5. Now that would be, that we read it, but look at our scale. Our scale is so different. So rise here is from 150 to 250, which is 100. Our run is 40. Notice that. If I were to just read it out just like this here, I'll be wrong because I have to look at my scale. My scale from there, from here is 150, this is 250, so it's 100. And the run is from 0 to 40, it's 40. So the rise, so over the run, is equal to 100 over 40, which is equal to 2.5. That's how that number came about. So our calculator complete this computation for us without us knowing it. So physically, we can, algebraically, we can calculate the slope of the line. Someone may ask how, that's how this came about. Okay. On the other hand, we had one example. Here's an example. So we have a negative slope here. So we have our rise, we're going down here, -3, and our run is 1, positive. So -3 over 1 is -3. The slope is negative. So if you have a line that is from quadrant 2 to quadrant 4, it's a negative slope. Quadrant 2 to quadrant 4. And you indicate it by a negative sign. Let's go on to now, these are special cases now. If you have a vertical line, it's referred to as undefined. It's a special case. Vertical line, there's no slope in this. It's not a zero slope. There's no slope. Or you can say it's undefined. You cannot determine a slope from this here. Now, if you have a horizontal line, you'll have a slope of 0. And so a vertical line, the slope is undefined. Okay? Because it doesn't cross the y-axis. So we'll write this one, for example, 1.5. You see this, the equation of this is 1.5. Notice there's no y-intercept. Okay? And every point on this line, the x-coordinate is 1.5. So if I go find this point here, this is 1.51, 1.52, 1.53. So x is 1.5, y is 1. here, x is 1.5, y is 2, x is 1.5, y is 4. Notice was consistent, your x is 1.5. That's why this could be written as x equals 1.5. That's the equation of this line. On the other hand, if you have a horizontal line, this is my line here, my slope here is 0, so m is equal to 0. What's my y-intercept? My y-intercept here is 3, so b is equal to 3. So I can write as y is equal to 0x plus 3. Or, since it's 0, y equals 3. So we can conclude horizontal line y is equal to the y-intercept, whatever the y-intercept is. A vertical line is undefined. And you can write this as x equal to wherever it crosses the x-axis, the x value. In this case, the x value is 1.5, so x is equal to 1. If we have a vertical line right through 3, the equation here, the x equal to 3. In this case, we have our horizontal line crosses the x-axis, y-axis of 3. This would be y is equal to 3 as my equation. Okay, let's look at some example questions. Now we've gone through a few of these. Remember, our equation is y is equal to mx plus b. So here's my equation of a line. So equation of a line is y is equal to mx plus b. So this is my slope. This is my y-intercept. Where it crosses the y-axis. So write down the gradient of the line, which is the slope of the line also. The slope of the line would be 3. This is my slope here. The y-intercept is 4. Okay, let's look up now. You're given us a find the equation of this line. So remember, y is equal to mx plus b. M is your rise, the run, and your b is your y-intercept. Firstly, we want to find b. So b is equal to where it crosses the y-axis. This is my b. So b is equal to 1. The m is your rise over the run. So let's find 2 points on the line that we can read off. It's much easier if you pick a point in between here. It's much more challenging to read, although this one is much easier. So I can pick 2 points. I can pick any 2 points in the line I can read off here and here. I normally try to select the point on the y-axis because it's clearly indicated, the value of it. Then I'll construct a vertical line. So this is 2 here. Then I'll do a horizontal line starting from my y-intercept. Then I count, like make sure I look at my scale here. So this is 1 and 2. So this is my run is 2. So rise of the run. So we got a run is 2. And then my rise, I count upwards from 1 here. So we have 1, 2, 3, 4. which is equal to 2. So my slope is 2, my y-intercept is 2. So y-intercept is 1, slope is 2. So my equation then is y is equal to mx plus b. Y is equal to m, which is 2x. Remember, these variables are there. You don't change them. Plus 1. So that's the equation of this line. So this is y is equal to 2x plus 1. Now, if you were to go ahead and enter this into your calculator, you will find this graph. And I'll just show you in a graphing calculator here for a minute, if you were to clear it. And I input this specific equation in my calculator. I'll press my y equal button. I'll clear my button here, so I get here, and I'll end up with, now I'll reset my calculator. I'm different in my stat plot, I don't want that. This is from a previous calculation. And I'm gonna go to my window and make that standard. Okay, now I'm gonna input the equation in my calculator here. So y is equal to 2x plus 1. And graph. Notice it crosses the y-axis as 1. Now I'll zoom in here, and so you can see that it crosses the x-axis as 1 here. Similar to what we have. If I were to extend this, be 3. Now I'm going to change my window to go up to 7, same as here. And I'll start from 0. My x minimum is 0 here. My y minimum is 0. My y maximum is 7, and my x maximum here I have at a 6. So I'll put this up at 6. So my window look almost alike as the one on the graph paper here. Now, there's no grid lines here, so it's very difficult to read it off. But from my equation, slope is 2. To test if this is correct, let's look at this here. When x is 2, y is 5 here. Okay. We recall one of the things we need to find when you're given the x value. So x is equal to 2, y is it 5? Let's see what our calculator should give us 5. So remember what we do. We press second trace value. X equals 2. And y is 5, so this matches up to our equation. This is one way of verifying your equation with your graphing calculator. Let's look at, here we have now we have a different line. So go back to my equation. I'll just zoom out a little bit here. So recall y is equal to mx plus b. We need to find the m and the b. So m is the rise over the run, and the b is your y-intercept. So first I'll find your y-intercept. It's -1. So you put here -1. Next, my rise. Now pick 2 points. It doesn't matter which 2 points. And here's the easy one to pick because they're right on this one in the x-axis, -1 here. This is on, sorry, the y-axis is -1. The x-axis is 1. So we'll construct a triangle here. This is 1, There's one. Sorry, this is 1. This is going up is positive 1, and this is 1. So 1 over 1 is equal to 1. So my m is 1. So I can write that as y is equal to 1x minus 1. Notice the y-intercept is negative 1. You could have selected, let's say we select this 2 points here. This is my slope. But here's 2 over 2. So 2 over 2 is still 1. Same as what you have here. So your slope should be the same regardless of what 2 coordinate points you select as your reference points. Okay, this is another one. Now you can try this out. I just want to do a negative slope here. Although this is on the blog under today's assignment for you to complete. So here we have an example of a negative slope. Our y-intercept is negative 1. So we say b y-intercept is negative 1. My slope, which is the rise of the run, you select 2 points that you can read off on your line. So I pick these 2 points here, or if you're not happy with negative points, but I'll just do one with negative point to show you from here, -2. Let's say go up to here, so you can read these 2 off. Then I'm going to construct this is my rise, and this is my run. Your run here is 1. Write it down as 1. My rise actually going down here. Going down 1. Look at my scale here. 1, 2. -2. So -2 over 1. So this equation is a negative slope, has a negative slope. So -2x minus 1. Or y is equal to mx plus b. So your b here is -1. Your m is -2. So this indicates to you your negative slope. So try this example, another example. It's on your first assignment. So find your y-intercept and then derive your slope using the slope-intercept form. I just want to complete a different, sometimes an equation looks different than what you'll see. Normally, you'll see, what we've looked at so far, an equation in standard form, which is y is equal to mx plus b. Now, what if it's not? So we have to do some algebra to isolate the y. So we isolate the y, 7x. We want to take the 7x to the right side. It's positive here, so I subtract both sides. Subtracting 7 minus 7x is 0. But whatever I do on one side here, I add exactly on the other side. So I'm left with y is equal to 8 minus 7x, because this is in front of the variable x. This is my slope. That's so -7 is the slope, and 8 is your y-intercept. So the slope here is -7. Y-intercept equals 8. Okay, so the next one is very similar. Now the final one, there are more on the worksheet, but I'll just want to look at this example here. This one, the x and the y's are all on the same side, same as even as the y-intercept is on the same side. We need to isolate the y. So first of all, what you want to do is to take the x and the 9 to the right. How do we do that? We subtract negative 6x on the left, negative 9 on the left, and you would add it to the right side, meaning that you have 6x minus, let's put the equal sign here. So I have negative 6x here, I have negative 6x over there. So I added this piece here. Plus 2y, I leave that, I want the y by itself. Plus 9 minus 9. So I added minus 9, so the 9 and the 6x becomes 0. So I'm left with 2y is equal to negative 6x minus 9. Now, I want to get rid of this 2 because eventually I want to find an equation that looks like this. This might be negative, this might be negative. That's okay, but the y, you want the y by itself. Isolate the y. So now, because you're multiplying by 2 here, you divide both sides by 2. So 2 divided by 2 is 1. So we're left with y is equal to negative 6 over 2x minus 9 over 2. So this could be simplified as negative 3. So y is equal to negative 3x minus negative 4. Negative 9 divided by 2 is negative 4.5. So your slope is negative 3. So we have here slope. Now where it crosses the y-axis is 4.5. Negative 4.5. So this is a negative slope with an intercept of negative 4.5. So I'd like for you to try out a couple of these examples in your book. Now, what happens if you have a set of data and you want to solve an equation? So let's look at this set of data here. Plot the following points in a coordinate plane, find the slope and find the graph. So I'm going to have a coordinate plane here. And here's my coordinate plane. I'm going to create a scatter plot. Now, we can use our calculator, but I don't want to use it now. I'm just going to show you how to do it without a calculator at this point. So you're not wondering too much how did it come about. Now, let's find our point 0, 2. So here we have 1, 2, 3, 4, 5. So this is 1, 2. Here you have 1, 2, 3, 4. So first point is 0, 2, which is right here. Next point is 1, 3. Next point is 2, 4. 3, 5. Take a ruler, construct a straight line. I can extend this line, that's fine. The y-intercept here, right away we know it's 2. Okay. So y-intercept, so we can so y-intercept, can write that down here. Y is equal to 2. Make sure that this is straight here. My y-intercept is 2, so y-intercept is 2. Okay, the slope now, where the slope is the rise, so I pick 2 points here, these 2 points, I can read them off easily. Then construct a vertical line. This is zone 3 and this is zone 2. So this is my rise. And this would be a run. So we count from here 1, 2, 3. So rise of 3. A run is 1, 2, 3. So rise over the run, 3 over 3 is equal to 1. So slope is 1. Error. So y-intercept is 2. Slope is 1. So y, let's put this here. So we can say b is equal to 2 and m is equal to 1. So my equation then for this set of data is y is equal to you can rewrite this formula. Y is equal to 1x plus 2. So notice this set of data here gives you the equation of a straight line. Okay, and you can verify that in your calculator. Go to your graphing calculator or Desmos. I just have this handy here. I go to clear my y equal button, clear that, and I enter my equation. Which is y is equal to 1x. So you can leave it as x, but I'm just going to put it here just for emphasis. 1x, so it's your x button, plus 2. And that looks very similar, or identical to what we do here, except it's different scale. So this is your y-intercept, 2. Now, I can change my window to make it look, give you a little more clarity here. And here we have -1. Or I can put -5, as we have in our scale. I'll use a window almost exactly as what's here. Here I have my scale from -5 to 15, and it's from -5 to 10. So let's do that. So x minimum is -5. By the way, you have to press, when you put a negative, just move up a little bit here. Whenever you are putting in a negative sign, do not use the subtract button here. That's one of the operation. This is your negative sign way at the bottom. Okay, maybe you can't see that well. Okay, I'll show up. Okay. You'll need to use this sign as negative. So you're -5 here. Do not, if you were to use this sign in negative here, 5, and graph, you will not see that negative up there. So you try and change that window. Make sure you have, and do not use -5. You will just change back to something else. Okay. So use a negative, and you have -5. Y minimum -5. Y maximum is 10. So we have here. And x maximum is 15. So that's, yes, so 15. Graph. So that's what we have here. Let's see if we extend this line here. It'll cross the x-axis at -2. So exactly is -2 there. So this is the algebraic way of finding the equation of linear regression. So this is a linear regression or equation of a straight line. So for your activity, if you look just below this video, there is an activity for you to complete and complete it. And you may need some graph paper, but you don't have to use graph paper. You could use any blank sheet. And once you label your coordinates, make sure they're evenly scaled. A coordinate from -5 to +10 is probably sufficient, and -5 to +10, or -10 to 10. So that will work for any of these equations that I assign you. So let's go back to review. Today, our goal, or at least for this lesson, is to analyze the equation of a straight line. And we said that the equation of a straight line has this form, y equals mx plus b, where m is your slope. Where m is your slope and b is your y-intercept. And we can derive the slope by selecting 2 points on the line, and then we construct a right triangle using those 2 points and find the rise over the run. That's your slope. Rise over the run is the slope. The y-intercept is the way it crosses the y-axis. Now, this only works if you have a graph that you can find the y-intercept where it crosses the y-axis. Sometimes that's not possible because the scale is so huge. Right? And a couple of examples we couldn't find the y-intercept because it's way below the negative, it's way below here, which may be -100, -20, -30. One example which we did, that we had to extend our y-axis to negative, was this question about when we use for temperature Fahrenheit and Celsius comparison. And in this case, the y-intercept would be, this was my estimate, would it be -17.78. So this should actually be here. And the slope is it's a positive slope, so it's 0.5 is 2, etc. This should be y is equal to, yes, x is 0, and y should be 2 here. Okay, so this graph here, if we look at it, x is 0, y is 2, should be up here. So go back to our review. So m refers to how far it goes up or down. Gradient of slope. The y is how much you slide up or down. And here we look at an example we plot the points on the graph and then derive our equation of a straight line.